Hey students, thanks for joining. For this session, we're going to be reviewing how to write a polynomial from complex conjugate roots. So here, write polynomial from complex roots. That's tonight's topic. Have your paper and pencil and take your notes. So this is the walkthrough of the practice sheet I've shared. Please view this with me if you've already attempted this. Attempt the worksheet first and then try to walk through it with me. So let's see if we could solve these. So I'll hop to number 8. That's the first complex root that I see. They give us -1, -i. Instructions read, write a polynomial function of least degree with integral coefficients that has the given zeros. Extra wording to just say, these are the roots. X equals -1, x equals -i. So yeah, we know that this is an x value. And now let's write the polynomial from that. So the first thing you ask yourself, here, let me make this clearly different, is when you see a complex root, when you see I, our imaginary number, we know that these always occur in pairs. So we're not only going to have -i, we also have +i because they always occur in pairs. So if we have +i, then we assume there's also a -i. Here we have -i, we assume, yeah, there's also +i. So these are our 3 roots here. Here, but -1, that's nothing fancy there. So when we write our factors, we want each of these set equal to 0. So if I want to make this equal to 0, I'm going to add 1, bring to the left. So I'll have the factor x plus 1. I just moved the 1 from the right-hand side of the equals to the left. And now this equals 0. Add I to both sides, we'll have x plus I as a factor. And then to subtract I from both sides, we'll have x minus I. And here, let me add in some additional notes. Block that out. That's what we started with. Here we remember, assume pairs. That's what we did first. And now we're writing out the factors. From the roots. Here we recognize, where should I write this? And yeah, I'll squeeze it up here for you guys. A minus B times A plus B. To the same term, to the same term. One factor, it's being added, one factor is being subtracted. This is our difference of squares. One of those special patterns that help make things a little easier. And so we could go from this form, the form we're in, and here, let me put that in a different color. And what we could say that this is A, this is B, this is A, this is B. And we could go from this form to say a squared minus b squared. So this is something you should have in your notes, something you should be able to recognize and know when to apply it to make things easier. Because instead of foiling through, well, yeah, let's go this way. Yeah, instead of foiling through, because foiling, I think we make more errors there. So just one pattern that we recognize. So let's bring down this x plus 1. This is our pattern. So A, which is our x, B, which is I. We just took this to here. Recognize that pattern. Recognize special pattern. And we know what I squared is. I'll put that off as a side note. So we know I is equal to the square root of -1. I squared is equal to -1. So yeah, next line of work, let me rewrite that. Bring down this first factor times x squared minus I squared, which is -1. So minus -1. Tidy that up. Let's get rid of that double negative. X plus 1 times x squared plus 1. And yeah, this is pretty easy to FOIL here. FOIL, do your box method. We're just distributing through to get this to standard form. So what I'll have x cubed, x times x squared, plus x plus x squared plus 1. But I don't really like this order because my exponents aren't in order or aren't in descending order. So equals x cubed plus x squared, my next lowest exponent, plus x plus 1. That's our standard form. Exponents are in descending order. And yeah, now we could clearly see our leading coefficient, the degree of this function. And let's check our answer. This came with responses. Okay, yeah. X cubed plus x squared plus x plus 1. Perfect. Lines up with what they get. So, full view. And yeah, just a summary. Again, we were given just 2 roots, one of which, hey, we see this is a complex root. We know that they occur in pairs. So first we assumed it's pair. We have x equals negative I, but we also assumed x equals I. Made it so that each of these became equal to 0 to get their factors. So x plus 1 equals 0, x plus I equals 0, x minus I equals 0. That's where these factors came from. Dealing with these pairs, we'll get to this point where, oh, we're going to recognize our special pattern, our difference of squares pattern, and apply that to condense this, to condense these 2 factors. And then it's really just tidying up from there. Your algebra. We know I squared is equal to -1. Be mindful of your signs here. We just tidied up. Double negative became positive. And we rearranged the order for our standard form of polynomials where the exponents are in descending order. So I have all that written down. Pause it if you need. And let's try another one. All right, we have fresh space. You have a fresh sheet of paper. Writing down the new problem, number 10. They just give us -3 and 2√2. Same instructions, write a polynomial function of least degree with integral coefficients that has the given zeros. So we have, these are the zeros. That means x equals -3, x equals 2√2. And here we're not just going to have 2√2. This is going to occur as a pair as well. So we got 2√2 and x equals -2√2. So anytime we see a radical, anytime we see our imaginary number I, we assume it's pair. So that's a hint here. So yeah, here we'll have a polynomial of degree 3. One real root, 2 complex roots. So where to begin? So again, we want to get these equal to 0. So if I said x plus 3, that'll give me my first factor. X minus 2√2, that'll give me my next factor, and then x plus 2√2 gives us that final factor. So let's, and let me line that up. X plus 3, x minus 2√2, x plus 2√2. Oh, and I left it up there. So here, our difference of squares. Same A, same B. One is a minus, one's a plus. All right, let's not waste our time foiling. Bring down its first factor. And even I still like to do A, B, A, B. It's very clear which is which. A squared, x squared, minus b squared. So 2√2. And here I'll put that in parentheses, 2√2 squared. And I'll close that. So again, just difference of squares. One's plus, one's minus, same term, same term. X squared, b squared. We're subtracting. And let's just tidy that up. Let's get rid of that exponent. Bring down this factor. X squared minus 2√2 squared. So I could square the 2. Square the square root leaves me with just 2. And this is 8. So yeah, common mistake here. I make it 2. We overlook squaring both parts, and I think, I don't know why, sometimes we may come and say √2 squared 4. Common mistake. I do it all the time. But yeah, 2 squared is 4. √2 squared, it's 2. 4 times 2 is 8. Let me tidy that up. And FOIL, do your box method, however you like prefer to to distribute this through. So this is pretty easy to handle. X cubed minus 8x plus 3x squared minus 24. What to do here? Look at the exponents, they're a little out of order. We don't like to leave it that way. So x cubed first plus 3x squared minus 8x minus 24. And this is our polynomial from the given roots in standard form. So yeah, again, we recognized its pair. Wrote out all the factors. Recognized our difference of cubes. And just did the algebra from there. And was mindful of squaring a square root. So yeah, take a moment, get that in your notes. Compare what you did. Did you get it?